Yes guys, you heard correctly. I'm finally done with this autonomous mobile robot. I've been in a toxic relationship with it for the past few months now, but I finally got it done.
Okay.
Hey, test runs at the end of the video, alright? But for the past few months, I've been working on this, finally done with it. I am super happy because this caused me a lot of, learning problems that I wanted to share this video with y'all so that y'all could learn from my mistakes, implement them into your own projects so they don't take as long, you don't run into as many troubles as I did. Come on! So this video is going to cover all the main aspects of this autonomous robot, starting with the motor to the back wheels, followed by the H-bridge that connects the Nano to the motor. We have the servo motor to steer the front wheels, and an ultrasonic sensor so they can drive like a Roomba. We're also going to cover the budget, which this project cost me about 120, 130 bucks, 45 bucks for the actual Lego Bugatti car itself, another 45, 50 bucks for the Super Starter Uno R3 project kit, which is essential for anyone who is getting started into microcontrollers. They have all the parts, you can order them on Amazon, little off-brand Arduino kit to get started, With those two, followed by other smaller things like a soldering iron, a Vise Grip, something to hold the components that you're soldering, some electrical tape, etc. But overall, this project cost me no more than 130 bucks, which to me, right now, that's a little budget project car with something that you could create like this. But moving on, we're gonna start with the motor, something that gave me the most trouble. Alright, so like I was saying, did have some problems with the motor. It started off whenever I was trying to use this motor that came with this kit. It's a good motor, it's just I don't have a way to actually attach the part that spins on the motor to something. As you can see here, I tried some setups with this old previous motor. Nothing worked, it wouldn't spin, I couldn't get it straight. I had a lot of problems with this motor, so I decided to scrap it. I luckily had this old motor that I just kept for some years, and I was able to use it now. And I thought the best way that I could attach this, after looking through my assortment of Legos that came with the Bugatti car, was just to 3D print them out. So I 3D printed it, got it set up, and this was working good until I found some more problems with the load being transferred from the motor to the rear axle. As you can see in the videos, it bends a lot, it moves, and so I knew that I had to make this way sturdier. Starting off, I added a free spinning gear to the opposite side from where the motor is actually driving the axle, just to try to add some support. Crossbeam was added to the motor axle to provide more support and to reduce that up and down movement. I did have this support implemented in my 3D print, but I misjudged the distance and I had actually cut it off and used the Legos. Just remember guys, measure once, cut twice. The last thing that I had to reinforce was this side axle part, because originally it was just one beam going across, not attached to the actual frame down here, and I just added a little something so that this bar across will be attached to the frame. And again, making it a little sturdier. It's still some movement, but way better than before, and it's actually drivable now. Along with the motors, you need an H-bridge so that you can supply enough current to the motor and not fry the microcontroller. Something that I learned about. But what's nice with this kit is that also the H-bridge comes included. This is the H-bridge that came included. Obviously it's not in use. So unfortunately, after some coding to just try to get the car to go backwards, it doesn't seem to want to do that. So hopefully I did not fry the backwards pin on the H-bridge. So that's unfortunate. Luckily, there's other H-bridges that I was able to buy. I bought a pack of 5, I believe, of these H-bridges that do enough. The only thing what's different is that you cannot control the speed. With the H-bridge that came with the kit, you're able to control the speed. With this, I'm not, but that is fine for these purposes. I just want to go forwards, backwards, and do that. And this H-bridge allows you to have a V-in port, voltage in, current in from a separate battery source, and then the microcontroller has signals to send to either go forwards or backwards. But this is another tip to always use an H-bridge and be careful when delivering currents into microcontrollers. But that being said, that's pretty much everything with the motor. Just a secure hold into the frame. The axle is secure so it does not move. And then also have an H-bridge to supply the correct amount of current to the motor and not to the microcontroller. After that being said, moving on to the servo, which gave me little to no problems, believe it or not. But I just have it hooked up through the Legos. There was already a kind of mechanism so that the wheels can turn. I just placed the servo in there. It's not completely rigid, but it does the job. That's all we need for projects like these, but if I were to actually do it right, I would have to 3D print something to make it completely rigid. That's just satisfying. But servo, nice and easy. Now the ultrasonic sensor, I just have it plopped in here. I 3D printed this little piece to sit behind it so it wouldn't move while it's in use. But ultrasonic sensor is pretty easy. You have long enough wires stringing through the car going to the actual Nano. And then also soldering. Soldering was a big one for this project. I started testing with just the breadboard, but I knew to make it look good, to make it look presentable, I needed to just solder all the wires so I could fit them in the cabin. And that is what I did. Of course, like everything, it takes time, it takes practice. I messed up a lot, RIP, H-bridge, but learning opportunity. But with that being said, that's pretty much everything from this project. Mechanically, now we will go to the code. Now for the fun part, coding. I'm just gonna do a brief overview of the code. I will link all this code into the description, and I have a bunch of comments saying what each one does, but basically what we're gonna be doing is initialize all the variables that we're gonna be using. Then in the setup function, we're gonna set up all those pin modes if they're input or output, to receive or send the data. And then I have a serial.begin for debugging and testing the code, because you could put serial print lines all throughout your code, so whenever something happens, it'll print on the serial monitor and you can see how the code is reacting. But jumping into the main loop function, we will have a digital write enable to high. So we need that to be high for the H-bridge that I'm using. And in our main while loop, I'm calling a distance calc function, which uses the trigger pin and the echo pin and the ultrasonic sensor to calculate the distance that an object is from that sensor. And it will return that distance variable to be used in these if statements. Now I just have 3 if statements. If something's more than 40 centimeters away, it's gonna drive straight, it's gonna drive forward and point the servos in the straight position. If something is between 40 and 20 centimeters, it'll still drive straight, but it'll turn the servo to the left position to try to avoid it. If it can't avoid it and the distance gets to less than 20 centimeters, it will jump into this while loop, which will turn the servos to the right position, and it will reverse the direction of the car, so it'll drive backwards until the distance is greater than 50. And you do need to call the discalc function again, because this while loop, while it's inside of it, it cannot and will not read this function call right here. So you need another function call inside. Once it gets to greater than or equal to 50, it'll jump out of this while loop, out of the if statement, and it will find which one it is in after that. With that being said, that's pretty much all the code. I'm not using this but state function. It's just for a button, but yeah, that's gonna be it. One thing too to keep in mind when uploading to an Arduino Nano is if it's not working, try to change the processor here under tools to the old bootlegger. You can try that. That worked for me. It might work for you too as well. But with that being said, that's all of the code. Now let's get into the testing of the vehicle, which was not fun. It's not fun at all. And I'm just gonna test to see if it'll drive forward and backwards. You know it'll turn. Had a little servo up there, but now we're gonna test the motor to see if it actually works. So let's try it. I will need to put little holders for the battery, but let's see. Oh shit. Oh, let's go. Let's go. Don't run into the wall. Okay. Gears, but it drives forward and backwards. Let's go. Oh shit. Why are you going white? That's not good at all. Oh shit. Oh. Okay, I think the ultrasonic sensor is a little fucked up right now. Oh shit, I shouldn't touch that, but we are finally ready. Why backwards, bro? Why backwards? Alright. You know what? I got a good feeling about this one. Alright. God damn it! Come on! Fuck! For what? For what reason? You're going back in timeout. Okay, stop. Oh, come on. Okay. Oh shit. Alright, I'm just gonna like be a border here. Okay, no, okay. Oh, I lost the wheel. Okay. Alright. Oh shit. Okay, so it doesn't work good with things that are angled. But oh shit, okay. Alright, so I've literally just shoved a piece of Lego right here through the car to try to, hold the motor, keep force on the motor going in. Hopefully that works. We will see. Alright, come on. Alright, turn, back up, back up, motherfucker. Yeah. Oh, come on. Oh, that's sick. So it doesn't work good whenever the surfaces are angled. But holy shit, I will take that. Oh, let's go. Let's go. Yes guys, so as you can see with the testing phase, it did require a lot of improvement. After every test, I needed to improve at least one thing. This whole project honestly needed continuous improvement for kind of almost every aspect, except for the servo. I will say that I only needed to update that once. Servo was good, but other than that, it was kind of a shit show, but I got it. Hey, I got it here, got it working decently. And to say, I think I earned my Master Builder certification because 95% of this car came from the Legos that were in the box. I only had to 3D print this one thing, and I 3D printed the servo holder, but just to put a little Car's Garage on it. But in conclusion, this video is an overview of my process of this project. Let me know in the comments if it helped you out, or if there's anything that I could do better in my process. This was my first one, so I'll be improving on it as well. And I'd love to hear your feedback, and also if y'all have any other cool ideas for things to build. I will honestly probably take this car apart, use it to build other things, but yeah, thanks for checking in, thanks for tuning in, hope this helped you out, and have a great day.